You. All right. React Denver. Hello again. July 2024. I've been doing this for a while. Can't keep track. Anywho, we have a great talk. Web3. If you know nothing about Web3 like I do, I have to sort that out today. He's getting ready right now, so I'll just do a formal introduction. This is React Denver. Thank you for being here. Our host is the Trade Desk, where we're sitting right now. Fantastic folks, been sponsoring us for 2 years, over 2 years now. However, I am looking for an alternate host for the next few months. Our host is going on paternity leave, so if anyone has some leads, that would be awesome. Needs to hold about 10, 15 people. That don't need much. Anywho, bathrooms are out the door you came in, all the way around. Unfortunately, almost a complete circle. Can't get through the one door. Sorry. Front doors here do lock at 6 o'clock, so if you go out and come back in, have a buddy. Anywho, pizza, drinks in the coolers, go nuts, and you're good? Yep. All right. Join the Zoom so you can switch here. Join the Zoom friends. And the link is in chat. And you can get him set up. So I'm going to cut. And we'll get started here in just a moment. Second there.
Do I use the mic?
The mic will come off the TV. Okay. So mute your mic and audio. You should be able to screen share. Let's see. It's been a micro. At least it doesn't involve
Cool. Can folks hear me that are remote? That's one like a quick confirmation.
Yeah, usually they do.
Oh, amazing. Okay. Sweet. So this is a talk that I put together called An Intro to Web3 for React Developers. My name is Dan Cortez. I've been a front-end developer for about 10 years. I got into the crypto scene, but mostly on the development side of things, like around 3-4 years ago. And I think it's a really cool technology that has a lot of potential. And I'd love to, talk about what it is with you guys. So I'm gonna drop a link to the slides and everything after this talk too, and got some of my socials there if you want to connect. About the presentation, the goals are really focused on the technology and the things that this enables. So my goals are to give a solid understanding of the Web3 stack. So how you build the front end, how you build the contract that acts as your back end, how you connect all that stuff. Explain the value proposition of Web3, why you should care, why I care, that sort of thing. And hopefully encourage you to build something using Web3 tech. I think it is very, it makes some difficult things very easy. And hopefully I can kind of show that and you guys can be like, oh, I've got an idea for something that I can put together. So some non-goals for this presentation is explain the inner workings of blockchains. It's super interesting stuff. I recommend if you're interested in that sort of thing, like go learn about it. There's a lot of interesting concepts that, at least when I was learning it, it's not stuff that I was exposed to in the past. But you don't actually need to know how blockchains work to understand how Web3 works, how smart contracts work, and that sort of thing. I kind of think of it like you don't need to be able to like understand the inner workings of a database to use one. Non-goal is to go over every piece of tech that falls under the Web3 label. There's so much stuff under this umbrella. This is more of like the basics, smart contracts, connecting it to your front end, that sort of thing. And it's also a non-goal to give investment advice because I think, like this is so tied up with crypto that like a lot of people think Web3 and it's like immediately like tokens and investing and that sort of thing. I like to think about this more just as a technology personally. Like investing like scares me and I don't want to give myself more anxiety than I already have. So I tend to stick to the tech. So I'm going to start kind of by talking about like what is Web3 because it's one of these concepts that has like if you ask 10 different people what it is, you might get 10 different answers. To me, the lights are like freaking out right now. I don't know if anybody remote can see this, but if I seem distracted, it's because I am. But anyway, okay, so what is Web3? I think that it's fair to say that there's no one definition, kind of like a lot of things in tech, it's kind of squishy. But for me, the core tenets are that it's decentralized. So, instead of having like one company that has one server that owns all the data, it tends to go towards these like decentralized ways of doing things. So like, blockchains, especially like EVM chains, so like Ethereum-based chains, are essentially like a network of different nodes that act as a single computer. There are decentralized databases that could be considered Web3, where like those are completely not blockchain based, but you still have like different people essentially forming a network. It is multifaceted, so there's like a lot of different concepts that make up this thing that is Web3. So, like I mentioned, blockchain, like crypto wallets. There's technologies called like indexers that are like decentralized things that essentially look at all the data that's happening on chain and let you like massage it, manipulate it, and like, extract it. Yes, it's very multifaceted. Also, like tokens are Web3 depending on like how you are implementing them. There's like utility tokens and there's DAOs. Like there's so many things. Also an evolving concept. I think it's kind of like an emerging technology, although it has been around kind of for a while. But as time goes on, there's like new interesting technologies that are happening. So for instance, up until somewhat recently, if you wanted to interact with like a Web3 application, you needed to have like a browser extension wallet. Now there's a lot of companies that are making headway into abstracting some of that and making it easier for like end users to actually use these products. And I think Web3 is the vibe, and I don't mean that in the sense of like it's such like a vibe for us, but like it's something that like once you start like working in it, once you start getting exposure to these different projects, you kind of like you kind of feel like whether a project not falls under the umbrella of like Web3 or not, and like just because it's using like a smart contract doesn't necessarily mean that it is, and just because it's not using a smart contract doesn't necessarily mean that it's not. So that's like a more holistic what is Web3. But for this talk, we're going to focus on Web3 apps. So like actually building like technology. It's React Under after all. So for us, in the context of this talk, Web3 apps are widely distributed via the internet. It's Web3. They, for us at least, use Ethereum-based or EVM blockchains as a core part of their stack. There's different smart contract chains, like Solana, for instance, has a different system, a different programming language. We're going to be looking at Ethereum-based ones specifically. So like Web3 apps have users use their crypto wallets for some functionality. That's going to be a little definition of what a Web3 app is and what we're going to be looking at. And again, like a deep understanding of how blockchains work is not required. So I'm going to talk about EVM chains for a second. So the Ethereum virtual machine is the part of the Ethereum like system that acts as the distributed computer. So it's essentially a virtual machine, it's a name that like processes like all the bits and bytes that are like in the smart contracts. And when you, as a user, make a transaction, it's the thing that's actually like running the logic. And then you have essentially a network of all these Ethereum nodes that are validating that logic, making sure that things are happening in the way that they should be happening, and so on. So yeah, we're going to be talking about EVM chains a lot. So the Ethereum blockchain introduced the Ethereum virtual machine. It's a core part of it. It's not the entire thing. It is only like the processing engine. EVM chains are blockchains that use the EVM, which is kind of like, a circular definition, but Ethereum is not the only chain that uses the EVM. So if you've heard of like Base, which is Coinbase's chain, or Optimism, or Polygon, all of these use the same system. And what's kind of nice is that if you learn Solidity, which is the most popular programming language to develop for EVM chains, you can kind of like deploy your projects on any EVM chain. Sometimes there's like little differences between them, but for the most part, if you like learn Solidity and you can work on Ethereum or Base, you can actually work on a bunch of different blockchains, which is cool. So that was the part where I kind of introduced concepts. Any questions around any of these concepts? Yep.
Something I've never really wrapped my head around is the terminology of wallet. Like that, I feel like is just conceptually about money in my mind. And is it kind of seems like that's not the case if we're using it for just typical apps?
Yeah. So a wallet is basically this little piece of software, sometimes hardware, but let's just go with software, that holds on to your account. So kind of like how your wallet actually has different credit cards, different IDs. A crypto wallet has multiple different, or honestly, most of the time maybe it has one account, but you can have like multiple accounts in a wallet. Some wallets actually support different blockchains, but it's essentially this thing that has multiple accounts, and then you use those accounts to do certain things. My guess is that even in the like, Web3 application side of things, we stuck with the wallet term is because non-smart contract chains came before smart contract chains. So it used to be just a place where you would keep your accounts where you could send money or receive money. We just kept that term like after, even when it became more about like transactions and like sending data and like smart contracts. So yeah, you can just think of a wallet as the thing that stores your account. Any other questions?
Which coin should I buy?
That's investment advice.
Actually, no,
buy it.
just ask AI.
Point to buy. Don't buy any.
Okay, I mean, I will say, if you actually want to deploy things to blockchains, you have to pay gas, and gas costs whatever token it is. So you sometimes have to buy tokens, even if you don't want to invest. Okay, so now we're going to start moving into technology. So this is a pretty sad little diagram that I put together, but the diagram nonetheless. And what I kind of want to show is like how this stuff works. So in the center, you have the client, the browser, the person that is interacting with your Web3 application. And so you've got your blockchain, which can act as a database essentially. And in order to actually get data from that chain, you have to ask one of those nodes for the data. So like all the different nodes, like there could be like thousands of nodes in the network. But if you want some of that data, you just ask one specific node. It could be a node that you're running yourself, although that probably won't be the case. You'll probably be using some service that is called a node provider that will give you the data. So all these nodes have an RPC layer that you can basically be like, hey, node, like for this contract at this address, what is the value of this function? And it can return it. If you ask it for that data, it will essentially, like, it'll just give it to you. You don't need a wallet or anything like that. So read-only operations from nodes are yeah, you don't need a wallet and they're free. Which I've lost my label here, but that is the line that goes node provider to the client. Okay, but then if you want to post a transaction, so we just talked about like get requests essentially, and now a post request is a little bit different because if you want to post something to the blockchain, if you are maybe like modifying the state of the blockchain, you then need to sign a transaction with your wallet, which will use one of those accounts to use cryptography to basically say the person that is trying to post this is 100% the person that I say it is, and then the blockchain will trust that the right person is submitting a transaction. So in that case, what a client would do, so like let's say that I have like a to-do contract and I want to add a to-do, the client would like create the transaction, send it to a wallet, the wallet would use cryptography to sign the transaction, and then the client would post that transaction to the blockchain, and then the blockchain can verify that the thing that you want to do is allowed, and essentially post that. It'll like gossip it to all the other nodes, and then the state of the blockchain will be updated. Signatures are interesting because you actually you don't need to be posting something to the blockchain to sign something. You can sign messages just to prove that you are the person you say you are. So essentially, signing a transaction uses cryptography in a way where only the person with that wallet account can create like the output. And that lets us do some interesting things that we're going to see in a little bit. Cool. So basically, just to recap, if you got your browser, the blockchain's the database, and then your wallet is essentially the identity layer of this whole thing. Cool. So we're getting closer and closer to jumping into code. So what are we building? What am I demoing to like explain all these concepts? So pretend that I write tech content and I post it to my website, and I want to monetize my content by letting people subscribe for early access. I actually ran out of time and made it they need to subscribe for any access. So think like, a blogging platform, but you actually have to pay for the content. Because I want to own my own content, set the access rules, and mutate directly rather than joining a partner program or essentially giving fees to some third party. So that means that I need auth payments. And if I was writing my own blog to do this without web3 technology, I would probably not do this at all because that sounds awful. Auth payments, in my opinion, are probably the hardest things about being a web developer. And there's no way you're going to do that from scratch. So you start having to integrate services, pay people fees, and so on. But we want to do this with no third-party services that we are giving part of our subscriptions to. Cool thing about Web3 and smart contracts is that auth and payments are first-class citizens. So crypto wallets and accounts take care of auth, like we mentioned, signing a transaction guarantees that the user is who they say they are. And then also smart contracts and the BVM take care of payments. There is a keyword that you can add to your functions called payable. And that means that that function can receive tokens from the user, which is so dope. When I first started learning, this stuff, my mind was blown. You can actually send a function money that's I don't know. I thought it was really cool, I guess. So what our tech stack is going to look like for the front end, the website that's going to be running this thing, it's going to be React and Next.js, bootstrapped with a service called Rainbow Kit. WAGMI and VM are these libraries that make it easier to communicate with a node so that we can talk to the blockchain easily. WAGMI specifically is a wrapper around VM that gives you a bunch of hooks. So, hey, we're React Denver. We have a lot of awesome hooks to talk to the blockchain. For the content of this blogging platform, I'm just using MDX, which has first-party support on Next.js. I didn't know that until putting together this talk. And then for the smart contracts, we're going to write Solidity smart contracts that we're going to bootstrap with Hardhat, which is a system that makes it really easy to create smart contracts, deploy them locally, test them out. It does a ton of awesome stuff. So I'm actually curious, has anybody written Solidity code here before? Nice, we got one.
I did the tutorial.
I'm actually curious, what did you think? With like a JS background?
Yeah, no, it's kind of similar to JavaScript in some ways, so I enjoyed that. But it is a different language, so there's like a lot to learn.
Yeah, for sure. So my Solidity crash course is, we're going to look at some Solidity code in a second, but first, it kind of looks like TypeScript. I think if you are a TypeScript developer, you actually might have like a pretty easy time with it. Learning, like, I mean, it is a new language, of course, so it's going to be difficult, but like more so than other languages, it feels kind of normal. I don't know. I found it pretty, yeah, like I've seen it before or something. Contracts. So whenever we're talking about like smart contracts, they're really just classes. They're like encapsulations of data and functions that like manipulate the data. So yeah, I thought contracts were scary. I just think of them as classes. Solidity is strongly typed, so kind of like going back to the whole, it kind of looks like TypeScript. You do have to type all your variables. There's a lot more variables than in TypeScript, but that's why the docs are there, and you just read the docs, and eventually you learn all the types. When you're writing contracts, you often do a lot of management around like who can do what. So these contracts get deployed to this like open network where like, anybody can like see the data that's on this network and so on. So you tend to write these things with a lot of access control rules so that like only people that are privileged can do certain things. In our case, if you subscribe to our logging platform, then you can actually read the articles. So yeah, it's a lot of management around like who can do what based on like the rules that you need to set up for your system. As I mentioned before, payable means that you can send that function Ether. And then contracts can hold and transfer Ether. So you can have a contract that like, people pay, and then let's say that you like own that contract. You can then tell that contract to like send you the money, whenever you like call a withdraw function or, based on really any factor. And then finally, there's a thing called gas that I'm not going to talk a lot about, but I did mention that like if you want to be able to deploy something to a blockchain, you're going to need these tokens. So running so read-only operations are free. If you want to write anything to the blockchain, you have to pay gas, which basically protects the network from people just like DDoSing it. So there's like things like gas optimization, so you can write your contracts in a way where like your users spend less gas to do a thing. But I'm not going to cover gas optimization or anything like that in this talk. That's like a whole different talk and probably not fitting for React Denver. Okay, so can I blow this up a little bit? So this is an example Solidity contract. And nice. So at the very top here, we have a struct, which I'm going to skip over. We have this contract keyword and then a name. So this contract is called guestbook. And then we have a body. This is kind of why I mean like they're basically classes. So like this guestbook contract defines some data variables up top. So we have a string, which is public. All of our variables are public actually, but they don't have to be. You can say private, and then they wouldn't be accessible, but actually like all the data on the blockchain is accessible, so it's fine to make things public. But anyway, our guestbook has a string variable called about, and this just says this is Dan's guestbook. It has an address, which is a type in Solidity called owner. And then going back to that structs are basically like maps with like named keys. So the signature struct has two members, an address called signer, and a string called message. So what you can do with my guestbook is you can sign it. So when I deploy this contract, which is kind of like instantiating a class, this constructor function will run, and message.sender is going to refer to the person that deployed the contract. So when I deploy this, we're going to overwrite the value of owner with my address, assuming that I'm deploying it. And then we've got some functions. So signed guestbook can be, it's external, so anybody externally can call this function. It's payable, so it can be paid. The variable that it takes is message, which is a string. And here we have like, if the message value is 0, so if you don't pay this anything, it's going to revert, which is basically like throwing an error and say you have to pay to sign the guestbook. Otherwise, we continue and we're going to push your message, or rather your signature struct, with your address as the signer, and then the message as the message. Get signatures, just return signatures. And then finally, withdraw. I just added this so that, I guess, when I said that like contracts can like hold money and like send money, I could call this withdraw function since I am the owner. So it says like if the current message sender, so if the person that is calling this function is not the owner, throw an error. Otherwise, we're going to transfer money to the owner, and it's going to be the balance of this contract. So if everybody here, there's 3, 6, 9 people, if everybody like signed my guestbook with like 0.1 ether, I could withdraw 0.9 ether after you guys all signed it. And this is like I mean, this is a trivial contract, but it's also like a non-trivial contract in that it has like very, like it has like this idea of a guestbook, and it has like operations you can do on it. It can store money, and then you can like get the money out, which is kind of nuts. But I hope that looking at this, you're like, huh, like even if I don't understand like all the things, like why it says string memory, you're like, maybe like I can read this, like kind of looks like a class. And again, it's just like we've got our data variables in the class and then the functions. Cool. So now we're going to jump into the code. Is everybody ready to do that after looking at this single contract? I'm sure we're all experts now. Okay. So, here I have not only the presentation that I just gave, but 2 projects, Smaller World Client and Smaller World Contracts. I initialized Smaller World Client with Rainbow Kit. Real quick, Rainbow Kit, you do one of these and it creates a Next.js application with the thing that lets you connect your browser wallet, like essentially automatically. So let's actually just try this. So I'm going to call that, call it live demo client. And part of the reason I want to show this is just to be like I want to drive home this point that this stuff has gotten really easy lately because of the work of like a lot of really amazing open source developers. But yeah, like it used to be that you had to know like how to like plug all these things together, and now they basically have it down to one command. So if I cd live demo client and then yarn dev, and go to localhost 3000. Yeah, I get this Next.js app that has this message that says wrong network, but then I can switch networks. I can connect my my browser wallet. I can like switch to all of these. What's up? Can I zoom in? Yes. So yeah, this is like the result of just running the create Rainbow Kit, or yeah, create Rainbow me / Rainbow Kit command. And this is what I use to bootstrap this project. So I'm going to kill that process and then start. I'm actually going to first deploy the contract that we're then going to look at. But first I have to run a local node. So like I mentioned, Hardhat is this development environment plus a bunch of other tools. it lets you run a node like on your computer that you can then connect to. So you can like, instead of working with a real blockchain, you do everything locally. So now I'm running a local node here. Going to npx already have run this deploy script and deploy this contract. Then I'm gonna yarn dev over here, which is gonna start the client app that I built using Rainbow Kit. Sweet. Okay, so this is the example app that we're going to be looking at. It's what I explained before. Which account? No, we're good. Okay. So, side note, I don't have 9,999.9 ETH. So when you were running, side note, these are going to be tiny, so apologies. But when you run these like local nodes, Hard Hat gives you like all these accounts you can use. I just added one of these private keys to my wallet, so they come with like 10,000 each. When you stop the process, unfortunately, you lose all that cash. But yeah, so here I've got my Smaller World website. If I try to go to a article, it's like, yo, it's restricted. You have to subscribe to access it. So let's look at how this kind of works. So I've got the client, but let's actually start at the contracts, because this is like all the logic that I need to build this thing up. So I have this contract called the subscription manager. Here I said that, I don't know why I decided to do like a weekly price. So if you want to subscribe, it's going to cost 0.0005 Ether. One nice thing is that the Solidity language understands these like currency values. So you can just say like it costs this much Ether, and then it'll convert this number into like a really big number. This is all you have to know is that it knows what Ether is, and you can use decimals. You cannot use decimals almost anywhere else because Solidity only really works with integers. Cool. So this is a constant. So this is just like not going to change. Price per week is always going to be 0.005 Ether. I have a mapping of subscriptions. So a mapping being kind of like a key value store of like somebody's like address over here, and then when their subscription runs out, using like a timestamp. So it's going to be like an address over here, then like a timestamp for when their subscription is over. A function called subscribe, which takes a number of weeks. So I can say, I want to subscribe for 4 weeks, for instance. And then it's external and payable, so you can send some money. First thing that happens is that the subscribe function says, you must send me an amount of money, which is message.value, which equals to the number of weeks that you want to subscribe for and price per week. So if I want to subscribe for 4 weeks, that's going to be, like 0.003 Ether. And if I don't send the right amount, it's going to throw an error, essentially. Then it's going to figure out when my current subscription ends. So it's going to see, does the user have a subscription, and is it greater than the current block dot timestamp. So there's a bunch of these like keywords that you can use. So like for instance, like block has a bunch of members like chain ID, Coinbase, which is where the Coinbase company got their name from. Difficulty, gas limit, so on. For our purposes, message value is how much money is being sent to this thing. Block dot timestamp is kind of like date.now in JavaScript world. So it's going to say, when should your subscription end? If you have a subscription and it is greater than, and its end date is greater than now, it ends, like it currently ends whenever it ends. Otherwise, we're just going to reset it to the current block timestamp. So that if you lapse the subscription, we're not like adding it from the time that it lapsed. And then we're going to say your subscription ends at the current subscription at plus the number of weeks times 1 week. So Solidity also understands this concept of date units like weeks and hours and days. So you can actually just write like 1 week and then multiply that by a number. And then finally, we have this is subscribed function, which takes the address of a user and returns true or false, depending on whether or not that user's subscription ends in the future. So if the user's subscription ends is greater than the current block timestamp, we know that they're subscribed. And that's basically that's all the logic, right? Like somebody can subscribe, I know who they are. So like how does the front end work with this stuff? So when I compile, so Solidity is a compiled language. When I compile this code in my hard hat project under artifacts, contracts, subscription manager dot JSON, I get this thing called an ABI, which stands for Application Binary Interface. And this is basically a description of all of the functions that I can call on that contract. So for instance, is subscribed is a type function, which has state mutability view, meaning it's like a read-only function, and it returns a boolean. So this is gonna be consumed by our front end, so our front end knows what functions it can call on the contract. So that's basically it for the contract. Now, if we look at our front end project, we have this, here we have pages. A lot of this stuff is bootstrapped by RainbowKit. So for instance, like all these providers are added by RainbowKit. I added this signing provider to show something, but essentially in our pages, and I'm assuming I guess I was assuming that folks are familiar with Next.js, but Next.js does page-based routing, or rather folder-based routing. So under the pages directory, index is the home page, /articles/plug is going to be this component. So if we look at the home page, we can see here, like welcome to my website, welcome to my website. In this layout thing, which wraps basically wraps both this and the individual articles. I have this connect button, which comes from RainbowKit. And then I have this like if is signed in, or rather, if you're not signed in, there's a sign in button, and on click, we call sign message. So I'm actually going to subscribe. Well, first I'm going to prove one more time. So yeah, this is restricted. And if I subscribe for 4 weeks, earn I think that maybe didn't. Let's see if I can sign in then. See an article. Nope. Okay. So I think what is happening, so that subscribe failed. One of the things that happens when you're developing is that there's this, to protect against like your account being used maliciously, there's a thing called a nonce, which like every time you submit a transaction, it like increases this value and then it uses that for part of the cryptography. And because every time that you deploy contracts and you're working locally, all of that data essentially blows up and goes away. There's like a mismatch between what your wallet expects and the real world, I guess. So I had to reset my wallet data. So it's like, hey, like forget about the old nonsense. Anyway, so I just hit subscribe. I just signed in. If I go to Solidity Key Concepts, I can actually see this article now because I subscribed for 4 weeks. So like, how are we actually talking to the contract? Let's look at that and let's talk about APIs again. So under source, pages, articles, slug, I have this use article like custom hook. And here in my article page, I'm getting this signature and then passing the current slug and signature to use article, and then fetching the data for that article from my Next.js API. So if we go to that article, and this is the only API route that we have, the handler for this route gets the slug and the signature for like from the request. If there is no slug, it's like, yo, what are you doing? But otherwise it keeps going. Here we are creating a client using WAGME and Via. So like I said, those are the like helpers that help us communicate with these nodes. Essentially what's happening is that like I'm in development right now, so I'm saying like, hey, go talk to this node. Its URL is like localhost 8545. And then like WAGME and VM know all the things that they have to do to be able to talk to that node that's running on my terminal right here. Because again, we deployed the contract to like my local node. Cool. So we have a client, and in order to get that data from the blockchain, clients have this nice read contract method where you give it an address, an API, the function name that you want to call, and then the arguments. So if we look at subscription manager one more time, our front end wants to call is subscribed, right? And here is subscribed takes a user as the argument and returns true or false. What's really cool about WAGME and VM is that they do a lot of like type inference based on the API. So what I did, by the way, is like I copied like from the artifacts folder that I showed earlier. I just copied the address that we deployed from, and then the like the API, and just pasted it in here. And that means that this, if I try to pass it like an argument of like number, for instance, it's like, yo, like it knows that is subscribed takes a string, because that's how addresses are represented. And also it knows that the return value is a Boolean because it subscribes returns a Boolean. So this is like all, okay, so took our contract, deployed it, subscribed, and then to get that data from the front end, or like rather from like a Next.js API route, all you do is make a client and then call read contract and just tell it like at this address with this API, this function name, here's an argument, and this will just return the value. So our article endpoint, if you are not subscribed, will return restricted access to access this article subscribe. And one more time, I go here. Yeah, that's what we see until I sign in. And then cool. So that's what it is like to get data out of the blockchain from a API route. It is like, I guess, just as easy to get it from the front end. Oh, actually, I don't have anything that's getting data from the front end because everything's behind that article's endpoint. But okay, so one more thing. I don't know if you guys have noticed, but when I refresh, I see this sign in thing, and it's not until I actually sign in that I can get the data from the API. And there's a reason for that, which is that to technically people can like fake the networks. So like the API, like let's say that the front end was just sending the address for the current user, and I knew that like somebody had a subscription already. You could just send the API like an address that has the subscription, and the API would be like, okay, I guess you're subscribed, so here's your content. But like one of the things I mentioned earlier is that you can actually just sign transactions and not send it to a blockchain. So one of the things I set up here to prevent people from like hacking my super secure logging platform is that in providers, I have the sign-in provider. And basically, this thing is using from WAGME this use sign typed data function. And when when we call sign type data async with this payload right here, which this is like, I don't know, pretty long data, but we call it with this payload, we get a result, and then we set the result, which looks like this. So I'm going to sign in. So my browser wallet's like, yo, sign in to Smaller World. And I sign. This isn't like going anywhere. Like that data is not actually being sent to like the blockchain or any API yet. All I just did was like sign this message in a way that proves that I have the account that I say I have. And then when we actually like click into an article, so going back to source, pages, articles, slug. So the sign-in provider, after I've signed, will pass the signature along to like any front-end component that wants it. So here I'm getting that signature that I, previously signed, and then passing it to our API. And this is gonna close the loop in just a second. But yeah, so use article calls article here, and now we're in like the server side of things, right? So I passed the signature, and like my backend has a way to recover the user's address if I know what data they signed and their signature. So now I know that the only person that could have possibly sent me this signature is the account that signed it. So that's how I'm actually getting the user's address in a way that can't really be easily hacked or abused, I guess. And then finally here I'm using user address as the argument of the is subscribed function, which, yeah, we just looked at that. Sweet. So this is, again, the contract right here. If you're curious, so, I had to like deploy this. The deploy script to deploy this contract is literally this. Like there's so many niceties that like Hard Hat gives you to like make deployment of stuff easy. So I just say like hre.vm.deploy contract and then like the name of the contract, and it knows to compile the contract, figures out which one has this name, and then like deploys it locally. And then finally, let's say that you wanted to deploy this to an actual blockchain so that you're done working. You like made sure that everything works correctly. You add the networks. So now I'm in like the Hard Hat project, right? You add the networks that you want to support here. So this is going to be like base Sepolia. I mentioned Alchemy. So what Alchemy is, Alchemy is essentially like a hosted node. So instead of like sending requests to my like local running process, I send it to this actual Ethereum node that's being hosted by Alchemy because I don't want to host one myself. And then for the account, I'm going to use the private key of the account that's going to deploy this, which I have here in my like .m. Which to be fair, I mean, like I did make this account like just before this, but I'm still not going to show it because you should never show private keys to anyone. And then if I wanted to deploy that, in the beginning where I did like npx hard hat scripts deploy localhost, I actually just changed that for the name of the network that I'm using. And this isn't going to work because I know that that account doesn't have any Ether. But that's insufficient funds for transfer. But if I were to send myself some Ether and then run this again, it would actually deploy, in this case, to the base network at this URL. And then finally, if anyone does not have a wallet whatsoever, I'm actually just going to remove this Coinbase wallet from my browser. So this is like a fresh browser. I don't have a crypto wallet at all. Like I'm super new to this thing. Getting one is actually as easy as here I can just download this browser extension. Cool. And that's Chrome. Now I have this wallet. Create a new one. Yeah, so this is my secret passphrase. Now that you've all seen it, I can literally never use this again. This was my actual wallet. I would be freaking out. Never share any of this stuff with anyone. But since this is a demo, we're fine. So first word is satisfy, last word is claim. First word is satisfy. Claim. It's just asking me to like. It's like, yo, you really should save this. Good Lord. Oh, it's not letting me. So now I have a wallet. I can go here, go to add manage wallets, get my private key, which again, never show anyone. Really, don't do any of the things I've done. I could have sworn that was what I read. Okay, whatever. Well, if I were to remember my password, it'd actually show me my private key, which I would then use to drop it here, get some funds, or have somebody send it to me. Also, if you're developing on testnets, you can use what are called faucets to get like free tokens. So you can like deploy to test networks for free. And then this would work. And that's, yeah, I guess that's the end of the loop there. So we're going to jump out of the code. So yeah, deploying to a real network, pick a node provider. We were using Alchemy. We were deploying to base Sepolia. And then, yeah, I recap this stack. So these are all going to be, yeah, I'll drop the slides and have links to this. But like for the front end, initializing with Next.js and React.js, or Next.js and React, Rainbow Kit makes that super easy. Hard hat for smart contracts. Again, you can like run a local node, write contracts, compile them, deploy them, even like test them. And then the node provider that we were using was Alchemy. And that's basically your whole stack. Other tools and concepts we didn't cover. Like I said in the beginning, this is like multifaceted. So yeah, we've got oracles, which are ways to like get off-chain data on-chain. So there's like oracles for like temperature or like who won yesterday's sports games. Indexers make looking at on-chain data easier. You can like manipulate the data, and like massage it in the way that you like your app wants to consume. There's things like IPFS, which is like decentralized file storage, XMTP, which is decentralized messaging, and bridges let you like send transactions from one chain to another chain because normally these chains are completely like self-contained. Cool. So almost to the end here, but like, why do I care about this stuff? For me, it feels like what would be the biggest step back towards like the original vision of the internet. I grew up with like AIM and like a lot of like systems with like open APIs and like, I don't know, I feel like the internet that we were promised was open and you could like build things off of things that other people build with like interoperability, and like that is not where we are today at all. And I'm not saying that Web3 does this, but like the vibe tends to lean that way. And I hope that we can kind of be like, if we are building in this system, we should try to like bring back the like ethos that I feel like we lost at some point. So yeah, that was my talk about an intro to Web3 for React Apps. Any questions?
Okay. So in this example, you have Next API, which I guess you would have to like host on your own server, and then that's communicating with the contract. Are there types of apps, or have you ever worked on apps where like you're mainly just dealing with the smart contract? So like towards the end, you mentioned oracles. Like, would it be possible to make a smart contract where that's the only thing you're interfacing in versus having to call an API?
So yeah, that's a really interesting question because those apps definitely exist, and there's also apps where like you'll have like smart contracts where like that's the core logic, and you can have like different interfaces, or maybe it's completely headless, right? So like let's say that like let's use Uniswap as an example. So Uniswap is a smart contract that's deployed out there, and it lets you exchange tokens. So you can exchange like Ether for USDC or USDC for like some other token, whatever. I would say 99% of people use that through the UI, but you don't have to, right? Like the UI is just like a way to like interface with this thing. You can just make those API calls directly to that node. Yeah, I'm sure that there's like traders and people that like take advantage of, there's a lot of like trading that happens with these DeFi applications where like, yeah, people aren't really using a UI whatsoever. In this example, we were kind of like leaning on like some of the things that Web3 lets you do to implement this like subscription model, but ultimately our data is being hosted like by Next.js.
Yeah.
But even in this example, you can kind of think like, okay, like let's say that you want to migrate to something else. You still have your like subscription data like fully on chain. So like it'd be really trivial for me to be like, I'm gonna like then take my Vercel hosted stuff and actually put the content on IPFS and then gate it based on the value of the blockchain that I deployed to. So yeah, I mean, I think like a lot of this is like mixing and matching technologies, and yeah, you can get like super purist with it and go like, it's everything in the stack is decentralized. You can use parts of it to make, you know, certain things decentralized. Yeah, it's kind of like a spectrum.
Yeah, thanks.
Yep.
When you go to deploy this actually on Ethereum, it's going to cost a little money.
Yeah.
Roughly, what is the dollar figures?
So it depends on the network, and yeah, it's like I mentioned, like the way that it's set up right now, which actually, yeah, I thought I wouldn't show this, but whatever. It's like this private key is an account that I've never used. So this is going to go to base Sepolia. So my Alchemy URL is specifically the base testnet network, and pretend that it was actually the base like mainnet network. That is going to be way, way, way cheaper than deploying on Ethereum directly. So like each network has like different costs. Ethereum for EVM chains, Ethereum tends to be the more expensive chain because it's the like canonical chain that yeah. So like Base is what's called like an L2. So you do a bunch of like transactions on Base, and then Base sends proof that everything that happened was legit to Ethereum, which is how it gets like those costs lower. But also it depends on how many people are using the network. So like if there's not a lot of people using the network, it'll be very cheap to deploy the smart contract. But if there's like a ton of people using it because like some big like, you know, NFT project dropped or whatever, it'll cost a lot more money. Yeah.
Does it cost per invocation?
Yep. So anytime that you want to alter the state of the blockchain, you have to pay for it.
So you have to factor in your weeks of cost, but not to always be inclusive of whatever the potential gas price might be in the future.
Yeah, I mean, like you don't really have control over how much gas costs at a moment in time. but you do have control over like how you write your contract so that the operations cost less gas. So like the subscription manager contract, like this subscribe function is going to cost the same amount of gas every time somebody calls it, but the price of gas might be different.
Yeah.
Yeah.
Exactly. So it's you're setting your price at 5,000 a liter, but if gas prices spike, you could end up actually costing yourself more money than you're actually bringing in.
Yeah, right. Yeah.
They only subscribe for 1 week. Like,
yeah,
you're actively losing money for that person.
Yeah, and like so if I deploy this, I'm not the person that's paying when the transaction gets submitted. It's the person that's like submitting the transaction. So
you're getting 1,000s.
Yeah, like I'm getting that
less gas. Okay.
Actually no. So yeah, like if in this case I would be getting 1,000s times weeks every single time, no matter what. And then the gas cost is added on top of that for the person that's submitting the transaction. Oh yeah.
Withdraw it.
Yeah, when I withdraw, I would be paying for gas. But like, especially with these like L2 networks, like Optimism, Base, the ones that like settle to Ethereum, and even like Ethereum gas prices have gone down too. But like transactions are super cheap. Like if this was actually on Base, to subscribe or to withdraw would cost like less than a penny.
And if it costs too much, you can potentially just nope out and come back later, right?
Yeah, I mean, yeah, you can see exactly how much it's going to cost you. So if you're like, oh man, it's really, yeah,
3 cents today.
yeah, which kind of, I mean, kind of goes back to like just giving the users like control. It's very like we like own this thing together, and like you can choose to use it however you want. Which is kind of cool. Also, I do want to point out that if I did deploy this, it's on the blockchain forever. So like, I don't have to think about like ongoing hosting costs or whatever, which is a really interesting and different approach to these like deployed technologies.
So if you made a mistake and you had to redeploy, is it a version thing? Are you overwriting the existing contract that was up there?
So the way that this contract is written right now, if I made a mistake, I'm like pretty screwed. So I'd have to be like, oh man, all the people that subscribed, like, I'm so sorry. There's like nothing I can do for you. I'm gonna like redeploy with the fix, but then like you all subscribed on the old one. But maybe I'm like a good person, and I can say, oh, I can actually see when that data for the previous contract, like as a subscriber, your subscription ends like next month or whatever. I can actually just like grandfather you in. So yeah, like there's upgradable contracts. Yeah, like we're really just scratching the surface here. Yeah, you can write contracts in a way where they can be like entirely upgraded. There's ways that you can write them in so that like you can add functionality while not making them upgraded, because some people are like, oh, like if you can upgrade a contract whenever you want, what's to stop you from like doing that maliciously? There's like this whole trust thing. Yeah, for the most part, if you deploy a contract like this and it's not upgradable and you have no way of changing it and you have a bug in there, it's trash and you have to redeploy a new one.
Which is why there's all those test nets and all that stuff. Try a bunch of times.
Yeah, right. Yeah, you normally like develop locally, test there, go to a test net, bring in users. They'll have like a test net phase. There's companies that do like contract audits, which will like they'll have super smart people like comb through like everything line by line, just to make sure that you don't have any like exploits. Because like, I mean, there's contracts that have like hundreds of thousands of dollars, if not more, and like an exploit can actually be like people's real money that goes out the window. And that stuff has happened multiple times. There's been so much money that's either been hacked or locked up because somebody just had a bug in their code.
Yeah. How much data are you, or can you, or do you normally store, I guess, in a contract? So like when we're looking at this contract right here, subscriptions is almost like a database. Like it's holding that data And I guess right now there's no limit on it, right? We can put as many as we want in there. So yeah, what have you seen? Like, how much can we store? Is there a limit?
As far as I'm aware, there is no limit to like what you can store. So, is anybody not familiar with the concept of like ERC20 tokens? So ERC20s are contracts that essentially are like how can I put this? Okay, so subscription manager, we were paying it in Ether, which is like the currency of EVM chains. ERC20s are these contracts that let you create custom tokens. And they only let you create custom tokens by virtue of like the code in the contract. So it's like it's a class that has like a mapping of who owns how many of that token. And I can't imagine that there's a limit to how many entries we can store because that would like break the underlying concept of the ERC20 token. So I think it just keeps adding it like the EVM just knows like, oh, add another entry at some memory address and we'll just keep track of like that memory address. Yeah. Something interesting. So like, is subscribed here. We're passing it a user, right? And saying like in this mapping of address to uint 256, like if the user doesn't actually exist in this mapping, you always get like these default values. So if you've never subscribed, you're not going to belong to that mapping, but I'll get 0 because that's the default value of an int. So yeah, like I don't know why like your question made me think of this, but it's interesting. Like, yeah, you can always like add data, but you can actually always ask these data stores for like anything, and it'll just return you like the default value if it doesn't exist. Cool. Any last question?
Like one last one.
Yep.
So about I have so many. About the nodes. So like you mentioned, I forget the name of the one that you're using, the public service.
Yep.
Are they completely free use, or do you have to pay a subscription to access that node? Or...
Yeah. So it's you do pay eventually when you're like initially building. It's kind of like the Vercel situation where it's like you don't really pay until you have to like until you have a ton of users. So yeah, like Alchemy like does have like pricing models, and also a lot of these companies have like a ton of different offerings that they use. So yeah, like maybe you don't pay while you're under a certain threshold for requests, but you use some other service that you pay for. So here you can see that yeah, you can make 300 million CUs, no idea what that stands for, per month. Yeah. I've yet to have to pay for Alchemy. So
Have you ever tried to self-host a node? Like, is that something people do, or are they typically reaching for services like that?
no, I've never tried. It just sounds like a lot.
Yeah, yeah.
You need like, I mean, yeah. Then you get into this whole concept of like, there's like light nodes and full nodes and archival nodes, and I don't know the time, man. But yeah, cool. Hopefully this illuminates some concepts. Hopefully it made it clear that Solidity is not that bad. Yeah, I truly believe that like for a lot of things, this is actually easier than traditional Web2 stuff. So yeah, I'm gonna end the presentation.
Yeah, that was great. Thank you. Built-in auth and payments, those are the hardest things. I was pretty interested about that. Yeah, I mean, it breathes right through that. You're like, oh, it made it click for me when you said ID in the wallet. So I always think of like credit cards in wallet, money, assuming that ID. Oh, play around with Stripes API.
Any questions for him before I like those? Peanut Gallery online. But it says thank you, very interesting. Will is probably taking dinner, so. All right, I'm gonna kill the feed so I can get this uploaded at some point tonight. So figure out how to stop that, and then